In this video, we are discussing about the built-in function. In Python, built-in functions are there. That means they are the functions already created by the developer. For example, int function in order to return the integer values. Then print function to display the values. Input function to input the values by the user. So these are the functions that we have already learned. So they are the built-in function. Along with that functions, we are going to learn about a len function, that is the length function. This function returns the length of a string, or it gives the length of a string. That means a equal to high, b equal to 4, 5, 6, 7. These all are enclosed in double quotes, so it is a string. Now c equal to length of a. Length of a means how many characters are there? 1, 2, 3, 3. So length of a is 3. Now c refers to the value 3 here. Print c, the output will be 3. Print length of b. How many characters are there? 1, 2, 3, 4. So we'll get the result as 4. Now print length of hello. 1, 2, 3, 4, 5. 5. So this is the output. And in this way, we will get the length of a string using the length function. So the built-in functions are int, string, float, complex, then bool. These are the functions we have learned. Then type function, then len function, then input function, then print function. So we have learned this much built-in functions. Then throughout this 12th standard, we will learn 12th and 11th. We will learn more about the built-in functions. In different chapter, we will come across different functions. Now next, we are going to learn about the mathematical functions. The mathematical functions are present inside a module called math. The mathematical functions are present inside a module called math. That is the math module. In order to use the mathematical functions in a program, first we have to write this statement, that is import math. First we have to write this statement import math. Then only it is possible to use the mathematical function. So there is a function called log. In order to get the logarithm of a number. Now I want to get the logarithm of a number 1. So what we will do? We will write like this. Math. First we have to write the module name. Math dot. Then we will write log. Then I am writing log of 1. So we will get the logarithm value of 1. In the same way, if you want to get the logarithm value of a number with base 2. So we can write like this. Math dot logarithm value of a number, that is 3 with base 2. This all you will learn in physics. Okay, so just understand that there is a function called log in order to get the logarithm value. That is enough for us. For your understanding, I have written like this. Math.log means we'll get the log value of 1, and here we will get the log value of 3 with the base 2. That's it. Now next is the log10 function. The log10 function is used to get the logarithm of a number of base 10. So in order to get the base 10 logarithm of a number, we can use the mathematical function log10. So it is present inside the module math. So we can write math dot log10, and inside that we can give the value 3. Now we will not give negative values for finding the logarithm. That is wrong. For example, if you are writing like this, math dot log of minus 3, it is not possible. Next is the sine function. In order to get the sine value, we can write like this, math dot sine 30. So we'll get the value of sine 30, or the value of 30. Then cosine. If we want to get the cosine of a number, that is cos. Cos function is there. We can write like this, math dot cos of 45. We will get the value. Then tan. If you want to get the value, tan value of a number, we can write the tan function, math dot tan. Inside the parenthesis we can give 15. We will get the value of tan 15. Next is the degrees function. If you want to get the degrees of a value, we can use the degrees function. That is math dot degrees. Inside the parenthesis we can give a value, then we will get that. Then radians. If you want to get the radians of a number, we can use the radians function. We can write like this: math dot radians. Inside the parenthesis we can give the value. So in this way we can use the mathematical function. So here we have learned log function, log 10, sine function, cos function, tan function, degrees and radians. These will not come to find the output, but sometimes in the question they will ask about the mathematical function, or write the names of two mathematical functions, or they will give a program code and they will ask you to find out the mathematical function. So you have to know these function names at least. For that, we are learning the mathematical functions. If you are interested in more programming, you can try all this. Next is the square root function. Square root function is used to return the square root of the number. So we'll write like this: math dot square root. Inside the parenthesis, we will give the number. Now import math a equal to 25. Print math dot square root of a. Square root of 25 is 5. 5 will be displayed. B equal to math dot square root of 36. That is 6. B refers to value 6. Print B 6. This is the output. In this way we can find the square root of a number. Now next, it is the power function. It returns the raised to exponent power. That means I am writing 2 raised to 3. So I will get the result of 2 raised to 3. 2 is the base and 3 is the power here. So we can use the power function POW, math dot power base comma exponent. So it will be like this: math dot power, inside the parenthesis 2 comma 3. That is 2 raised to 3. The output will be 8. Here I is small letter I. Okay. Now import math a equal to 5, b equal to 3. Print math dot power a comma b, 5 comma 3. So first one is the base and second one is the exponent. That is 5 raised to 3. It will be 125. Next, c equal to math dot power 2 comma 4. So 2 raised to 4, it is 16. 16 will be referred by c. Print c. The output will be 16. So in this way we can use the power function. Next one is the ceil function. When we are writing the ceil function, we have to write like this: math dot ceil. And I want to find the ceil value of a number, for example 9.8. If we are writing like this, we will get the next value, that is the 9.8, which is the smallest value that is near to this number, and it should not be less than this number. 9.8 is the number, and we have to get a number that is not less than this number. That is 10. 10 is the next value. So we'll get the value as 10. Or if you are writing like this: math.ceil 5.7. So we want to get the smallest integer not less than to this number. The next number is 6. We'll get the value as 6. So a equal to 5.6, b equal to math.ceil of a. 5.6, it will be 6. B refers to the value 6. Print b, will get the output as 6. C equal to 9.1. Print math.ceil of c. 9.1, it will be 10. So the output will be 6 and 10. This is the ceil function. Next is the floor function. It returns the largest integer number not greater than the number. Math.floor num. In this way we will write the syntax. Syntax means the format. Okay. Now I will write an example. Math.floor, inside the parenthesis 8.9. Now the question is, we have to find the floor of this number. It returns the largest integer not greater than this number. The floor function will give the largest integer, but it should not be greater than this number. That means we have to get a number, it should not be greater than this number. So the output will be 8. 8 is not greater than this number. That's it. So it will give the value, only the integer part. Next, we are writing like this: math.floor 6.5. We will get the result as 6. That is the largest number, not greater than this number. That's it. Now we can try this example. Import math a equal to 5.6, b equal to math dot floor of 5.6. So b refers to the value 5. Print b, we'll get the output as 5. C equal to 9.1. Print math dot floor of 9.1. 9.1 means we'll get the value 9. That is the largest number that is not greater than this number. So this will be the output. Next is the absolute value. It will give the absolute function means fab's function. It will give the absolute value. For example, absolute value of 5, it is 5. Absolute value of minus 16, negative 16, it will be 16. So in order to get the absolute value, we will use the absolute function. That is FABS. Import math a equal to 5.6, b equal to 3 minus 34.5. Print math dot absolute value of a, absolute value of 5.6, it is 5.6 itself. C equal to math dot absolute value of b, that is minus 34.5, it will be 34.5. So print C, the output will be 35.5. Next, we have to find out the invalid expression. Now see here, x plus into r. This is wrong because two operators are coming in continuation without any operand. So we should not write 10 expression like this. Q into a plus b minus z divided by 4. Here the operator is missed between q and a. For example, in maths we'll write like this, 3x plus 2y and all. But in Python we have to expand like this, 3 into x plus 2 into y. Like this way we have to write. We should not miss the operator. Now math.power 0, minus 1. When we are finding the power, the exponent should not be less than 0. Exponent should not be less than the 0. Then only it is possible to find the power. Minus 1, it is not possible. Now math.log of minus 3. We should not use negative values to find the logarithm. So that is also a invalid expression. So while you are writing an expression, you have to follow these rules. Now next, we are going to learn about two constants. In maths, we have learned about pi. The constant is 3.415. This is a long number. And e value, that is the exponent value, e, 2.7182 and all. So in order to get this, inside the math module, there is a constant. That constant value, pi. So if you are writing math.pi, we will get the value of the pi. Or if you are writing math.e, we will get the value of the e. So import math radius equal to 2, area equal to pi r square we know. Instead of pi, we can write math.pi then into radius raised to 2, then we will get the area. In the same way, we will get the value of e. Import math a equal to math.e, then we will get the value of e. In this way, there are two constants in Python inside the math module, pi and e. Next, we are going to write an expression for the following. Square root of a square plus b square plus c square. So how we will write? In order to get the square root, we are having a square root function inside the math module. So we'll write math dot square root. Then inside the parenthesis a square, we can write a into a plus b into b plus c into c. Now see here, p plus q, r plus s all raised to 4. So we can write like this, p plus q divided by, we can write power because here r plus s raised to power. So we can use the power function. When we are using the power function, we have to write math dot power. Inside the parenthesis, we have to write r plus s, that is the base, and raised to 4. In this way, we can write the expression for this. Now cos x divided by tan x plus x. So inside the parenthesis, we have to write math dot cos x divided by math dot, because we are having a function called cos x and tan x. Inside the parenthesis, we can write the value. Now close it, plus x. This is the expression. Now next question. 2 minus ye raised to 2y plus 4y. For this, we are writing an expression. So we can write like this, 2 minus y into, this is e. In order to get the exponent, we are having a function. Exponent is the exp function. So we can use that. We can write exponent. What is the exponent? 2y. So we can write 2 into y plus 4y. This is the answer. Now see here, e square minus x. E square minus x means absolute value. Absolute values are represented like this. So we are having a function called fabs. Now here, see here, sorry for the mistake, math.exp. Okay, we have to write like that, math.exp. If we are using the mathematical functions, we have to write math.square root, math.cos x, cos, math.power, like that. Now we are using the absolute function, so we have to write math.absolute function of e square. E square is exponent. So in order to get the exponent, we are having a function exp. So we have to write math.exp. Now what is the value of the exponent? 2. So we have to write 2 minus x. In this way, we can write the expression.